Hi students, welcome to chemistry classes. Student, in this class we are going to start the next concepts in electrochemistry, that is secondary batteries. In the previous class we discussed about the primary batteries. Primary battery means the battery which can be used only once and cannot be recharged. And secondary batteries. Secondary battery means they are rechargeable batteries. We can recharge it after use. The definition for secondary batteries: a battery which can be recharged after use by passing current through it in the opposite direction. A battery which can be recharged after use by passing current through it in the opposite direction is called a secondary battery. Here there are two types of examples in secondary batteries. First one is lead storage battery and second one is nickel cadmium battery. First one is lead storage battery and second one is nickel cadmium battery. Here, first one, lead storage battery. Lead storage battery, it is used in the automobiles and inverters. So student, lead storage battery means lead storage battery, here cathode and anode and electrolyte is present in the lead storage battery. Here lead storage battery, it consists of a grid of lead filled with a spongy lead as a anode. Here anode is a lead filled with a spongy lead and a grid of lead packed with a lead oxide PbO2, that is act as a cathode. Anode is lead filled with a spongy lead and cathode is lead oxide, and the electrolyte is a 38% solution of sulfuric acid H2SO4 is used as a electrolyte. So this is the lead storage battery. And the cell reaction. The cell reaction for a lead storage battery is, in anode lead Pb, and here we are going to take a electrolyte SO4 minus, means H2 plus SO4 minus, like this, means H plus HSO4 minus, it dissociate like this, but here we are going to take a Pb plus SO4 minus electrolyte. It gives rise to PbSO4 and it loses 2 electron, because in anode oxidation reaction takes place, that is why it loses 2 electron. And in cathode, here PbO2 act as a cathode, PbO2 plus electrolyte SO4 minus and 4H plus, it gains 2 electron because in cathode reduction reaction takes place. So it gives rise to the products PbSO4 and 2H2O. So here total overall reaction is Pb here and PbO2 and SO4 minus and 4H plus. These all combines to form a 2H2SO4. Okay students, Pb and PbO2 and 2H2SO4, 2 PbSO4, here PbSO4, 2 PbSO4 and 2H2O. These two electron get cancelled. And here this battery undergo a large number of discharging and recharging cycles. This battery undergo a large number of discharging and recharging cycles. And here reaction, it is mainly used in applications of lead storage battery it is mainly used in automobiles and inverters. So this is about secondary battery. In that first one, lead storage battery. So this is about lead storage battery. And student, second one, that is nickel cadmium cell. Nickel cadmium cell. Nickel cadmium cell. So this is the simple diagrammatic representation of a nickel cadmium cell. Here there are so many layers are there: positive plate and separator and negative plate. So here anode and cathode and electrolytes are used. Here anode is, it consists of a cadmium. Here cadmium act as a anode, and nickel hydroxide NiOH thrice, it act as a cathode. And electrolyte used in this nickel cadmium cell is sodium or potassium hydroxide. Sodium or potassium hydroxides or act as electrolyte. And here students, cell reaction. So here positive plate and negative plate are there. Means one is act as a anode, another one is act as a cathode. It is a type of a galvanic cell. Okay, in galvanic cell, cathode is positive, anode is negative. Okay, not electrolysis. It is a galvanic cell. So student, cell reaction, cathode. Here cathode is act as a nickel hydroxide. Cathode, here 2NiOH thrice. You already know, in cathode reduction reaction takes place, in anode oxidation reaction takes place. Cathode 2NiOH thrice, it gains 2 electron and it becomes 2NiOH twice plus 2OH minus. This is the cathode reaction. Next one, anode. Anode, here it consists of a cadmium anode. So anode, cadmium, electrolyte, cadmium plus electrolyte, it gives rise to cadmium oxide and water and 2 electron. In anode oxidation reaction takes place, that is why it loses 2 electron. And overall reaction of this nickel cadmium cell is cadmium here and 2NiOH thrice. So this 2 electron gets cancelled and 2OH minus gets cancelled. Cadmium 2NiOH thrice, it gives rise to cadmium oxide 2NiOH2 twice plus H2O. So this is the net reaction of nickel cadmium cell. And next one students, this battery gives a constant potential during its life because the net cell reaction does not involve in any ion whose concentration can change during its lifetime. I will repeat it once. This battery gives constant potential during its life because the net cell reaction does not involve any ion whose concentration can change during its lifetime. And one more important point here, the reverse reaction takes place during recharging. During recharging, the reverse reaction takes place, that is cadmium oxide, this one, cadmium oxide plus 2NiOH twice plus H2O, it gives rise to cadmium plus 2NiOH thrice. So this is about nickel cadmium cell. This is about nickel cadmium cell. And student, this battery gives a constant potential always, and it has a longer life than a lead storage battery. It is more expensive. So student, it has a longer life. Nickel cadmium cell, it has a longer life than lead storage battery and it is more expensive. And next one student, fuel cells. So fuel cells, it is an important concept. Fuel cell means galvanic cells that converts energy of combustion of fuels directly into electrical energy are called fuel cells. Example, hydrogen oxygen fuel cells. Okay. This